This motor here is kind of like the ones you're going to be using for your model wind turbines, and this is another motor exactly like it, and they're joined together with a flexible coupling here made out of some heat shrink tubing and a little bit of crazy glue to keep it from slipping. I've got the power over here that I can connect to a battery, and I've got the output connected into this circuit over here. This is going to wind up being the negative output for the direction it's going to spin in, and this is going to be the positive output. And I've got a whole collection of little resistors over here. Finally, I'm measuring voltage at a couple of points where this orange wire is plugged in and where this white wire is plugged in order to see what's going on in the circuit. Now it's easier to figure out what's going on if we look at a circuit diagram. So here's the motor, here's the generator, here's that flexible coupling, and then I've got the negative output going through this shunt resistor over here. This is a really low resistance, about 1 ohm. Then connecting straight to ground, that's my negative reference. I've got two resistors here that are 2K each, and I've got the point in between them connected to the analog input number 1 on my little microcontroller over here. I've used this voltage divider in order to get this voltage to be a little bit lower than the actual voltage that's coming out of the motor. That's because this particular microcontroller only runs on 3 volts, and if I put 5 volts into the analog inputs, that could burn something out. So instead of 5 volts, I'm going to get something like 2.5 volts, dividing about by 2. Over here I've got some more resistors. This first one, brown, black, red, we know that that's 1K. The next one is a precision resistor. I don't have the color code, but it's about a 100 ohm resistor. The next one here is a 56 ohm resistor. And finally, this great big guy here is a 10 ohm resistor. I've picked a 10 ohm resistor here because if I put 5 volts into this load, I'd have a current of about 500 milliamps. That would be about 2.5 watts. These are quarter-watt resistors, so I'd better make sure that I don't get up that high with these little ones. But this big one, if we can get up to 5 volts and drive it through it with half a milliamp, that'll be 2.5 watts. That's a fair bit of power output. And then I can use a jumper wire to decide which of these resistors I want to connect. I'm going to plug in a 9-volt battery now, that's this guy, to get the motor to run. And if I plug the multimeter in to this side, so that's the overall output of the motor, I'm getting about 3.5 volts out of the motor. If I decrease the load on the motor by unplugging the 1K resistor, I get a little higher frequency, it's going a little faster, and I get 3.8 volts. If I put it into a higher load, the speed went down, and I'm getting about 2.8 volts. If I put it into that 56 ohm, I'm getting about 2.4 volts, slower still, but maybe I'm getting more power out because I'm probably getting a higher current. Finally, if I plug it into the 10 ohm, speed goes way down. I get about 1 volt out. So I'm not getting as high a speed, but I'm getting considerably more current. That's about 30 millivolts there. If I knew the resistance precisely of this resistor, I could convert that 30 millivolts into the current that's flowing through that resistor. If I disconnect the load, the voltage goes way down to about 1 millivolt. Very little current flowing. Small load, 4 millivolts. Larger load, 27 millivolts. larger load, 42 millivolts, and really big load, 87 millivolts. I take the load off, the speed goes way back up, and the current measurement is much lower.